Optimus Gen 3 operates at a velocity of 6.8 miles per hour, rendering it suitable for integration within industrial environments without causing disruptions to ongoing operations. This capability exemplifies Tesla's substantial investments in advancing technology and mobility. In contrast to other humanoid robots primarily focused on agility, Tesla places a strong emphasis on the optimization of Optimus's hands. This prioritization enables the robot to execute intricate tasks, including cooking and cleaning, with remarkable efficiency. Elon Musk envisions Optimus Gen 3 as an invaluable asset across multiple sectors, particularly healthcare, where it could play a supportive role in surgical procedures. This perspective underscores the robot's versatility, extending its potential applications beyond mere household functions. The deployment of innovative battery technology featuring 4,680 cells empowers Optimus Gen 3 to function continuously for up to 10 hours without the necessity of recharging. This represents a significant enhancement compared to previous robotic models. Optimus Gen 3 employs sophisticated artificial intelligence systems to learn from real-world experiences, mirroring the learning processes of humans. This advanced capability facilitates intelligent interactions with its surrounding environment. To refine Optimus Gen 3's performance, Tesla gathers human motion data that allows the robot to replicate actions with exceptional precision. This training process involves employees utilizing motion capture suits to meticulously record their movements. The robotic hand of Optimus Gen 3 is engineered for both flexibility and precision, thereby enabling it to execute delicate tasks with a degree of dexterity and smoothness akin to that of humans. Such advancements mark a significant progression from earlier robotic models. Incorporating tactile sensors and miniaturized actuators, Optimus Gen 3 effectively addresses the limitations encountered by robots in the past, enhancing their capacity to perform tasks that require sensitivity and responsive feedback. This technological development permits safe handling of fragile objects. Elon Musk foresees a future in which robots like Optimus Gen 3 render work optional, fundamentally transforming the dynamics of labor and daily life for human beings. Such projections prompt critical considerations concerning the evolving nature of employment. The integration of Optimus Gen 3 into manufacturing facilities has the potential to considerably enhance productivity by automating intricate and repetitive tasks, encompassing roles in assembly and quality inspection. Designed to undertake hazardous tasks that may jeopardize human safety, Optimus Gen 3 is adept at operating heavy machinery in perilous environments. This safety-centric approach contributes significantly to fostering a healthier workforce. Tesla has set an ambitious objective of producing millions of Optimus Gen 3 robots on an annual basis, aiming for widespread application across diverse industries ranging from healthcare to manufacturing. This aspiration signifies Tesla's unwavering commitment to pioneering innovation. Recent advancements in artificial intelligence and sensor technology empower Optimus Gen 3 to function proficiently in real-world settings, adapting to human gestures while executing precise tasks. This capability represents a transformative shift in how we engage with technology. Elon Musk underscores the importance of accessibility concerning Optimus Gen 3, asserting that it should be available to all individuals, not solely the affluent. This initiative aims to democratize robotic assistance, thereby benefiting a wider demographic. Ultimately, the mission of Tesla's Optimus Gen 3 is to liberate individuals from the constraints of repetitive labor, empowering them to concentrate on more enriching aspects of life. This paradigm shift harbors the potential for fostering a more balanced approach to work and personal well-being. Tesla Bot Gen 3 integrates cutting-edge battery technology, which enables it to operate for durations exceeding those of any humanoid robot currently available on the market. This significant advancement effectively addresses the energy consumption challenges that have historically plagued other robotic systems. In this context, Elon Musk envisions a transformative future wherein robots undertake all forms of physical labor, thereby allowing humans to concentrate exclusively on management and strategic decision-making. Such a paradigm shift could fundamentally redefine societal notions of work and income distribution. Moreover, the potential applications of the Tesla bot extend far beyond mere productivity enhancements. It could serve as a solution to pressing societal challenges, such as poverty alleviation and improved healthcare access. By fundamentally altering human lifestyles and economic structures on a global scale, this innovation promises significant implications. Furthermore, the weight reduction achieved in the Optimus Gen 2 contributes to enhanced energy efficiency, enabling the robot to execute more intricate actions while maintaining a comparable battery capacity. This modification exemplifies Tesla's ongoing commitment to optimizing the performance of its robotic systems. As for Optimus Gen 3, it is anticipated to incorporate a 4,680 battery cell, potentially extending its operational time to 14 hours. This advancement not only illustrates Tesla's dedication to enhancing the endurance and functionality of its robots, but also positions Optimus as a formidable asset in various applications. The forthcoming commercial release of Optimus is poised to empower the robot to undertake an extensive array of household tasks, while also demonstrating potential utility in medical settings. This versatility highlights its promising role as both a domestic aid and a healthcare support companion. Additionally, Optimus' capacity to interpret human gestures facilitates intuitive interactions, which proves particularly beneficial for users facing communication challenges. For instance, simple gestures such as pointing can elicit specific, programmed responses from the robot. Elon Musk posits that as production scales up, the cost of Optimus could decrease significantly, thereby enhancing its accessibility for a broader consumer base. The ambitious objective is to manufacture 1 million units annually, which could spur widespread adoption. The integration of Tesla's state-of-the-art 4680 battery technology endows Optimus with capabilities that are unmatched by existing robotic solutions, thereby enhancing its attractiveness for both commercial and personal applications. Moreover, Optimus is projected to serve as a cost-efficient alternative for executing labor-intensive tasks. This innovation allows owners to recoup their investments swiftly through significant gains in efficiency and productivity. The versatility of Optimus, capable of functioning across various sectors, including restaurants and warehouses, underscores its potential to optimize operations within diverse industries. Such adaptability positions it as a valuable tool in modern business environments. Nevertheless, ensuring the safety and security of a humanoid robot like Optimus is paramount. This presents unique challenges, particularly concerning safeguarding against cyber threats and ensuring safe interactions within human-centric environments. To address these concerns, a multi-layered security architecture is employed, incorporating encryption, real-time monitoring, and AI-driven firewalls. These measures are designed to thwart unauthorized access and ensure the secure operation of the robotic systems. Additionally, the learning capabilities of Optimus introduce distinct challenges related to the prevention of misuse or tampering. Therefore, prioritizing ethical AI development alongside robust cybersecurity measures is essential for the safe deployment of these advanced robotic systems. In conclusion, Elon Musk emphasizes that Optimus will only be released to consumers once it adheres to stringent safety standards. This underscores Tesla's unwavering commitment to prioritizing user safety and ensuring the responsible integration of robotics into everyday life. Exhibits a broad range of capabilities, encompassing tasks such as cooking, cleaning, and even managing waste disposal, thereby establishing itself as a versatile household assistant. This functionality positions the bot as a substantial enhancement to daily life. Musk's confidence in the Tesla bot is rooted in the company's technological advantages over competitors, including the Xpeng Iron Robot, which does not offer the same comprehensive household functionalities. This competitive distinction may ultimately consolidate Tesla's dominance in the robotics sector. The global emergence of humanoid robots prompts critical discourse regarding potential job displacement, with Musk proposing that the nature of work may transition to a more optional paradigm. Such a transformation could profoundly impact societal structures and economic frameworks. The economic implications of Optimus are noteworthy, as it could potentially offset its acquisition costs within a period of 2 to 3 years, thereby generating income for its owner, while simultaneously contributing positively to societal welfare. This aspect accentuates its viable economic advantages. Musk asserts that Tesla's pre-existing technologies, including the components leveraged in their automotive production, sufficiently equip the company to lead the robotics market. This assertion emphasizes Tesla's distinctive advantages in the development of humanoid robots. The design philosophy behind Optimus entails a deliberately non-human-like appearance, aimed at mitigating any discomfort among users. This strategic approach could enhance the robot's acceptability within everyday environments. The engineering framework of Optimus necessitates comprehensive data collection and motion training, aimed at accurately replicating human actions. This process incorporates the use of motion capture technology executed by trained personnel. Optimus operates within a decentralized learning network, facilitating the instantaneous dissemination of newly acquired skills among all robots. This innovative structure ensures that each unit becomes progressively more intelligent with every task it learns. A comparative analysis between Tesla's Optimus and Xpeng's Iron Robot underscores notable distinctions in both appearance and functionality. While Iron Robot emphasizes human-like features, Optimus is specifically designed to prioritize effective task execution. Tesla's Optimus is purposefully engineered for industrial applications, placing a premium on safety and efficiency rather than advanced mobility features. This method facilitates predictable interactions with tangible objects in real-world scenarios. The competitive landscape between Tesla and XPeng illustrates contrasting strategic approaches. XPeng concentrates on fostering emotional engagement, while Tesla remains committed to enhancing functionality, particularly within manufacturing environments. Musk identifies three principal challenges inherent in robotics: the engineering of functional limbs, the creation of reliable artificial intelligence, and the logistics of large-scale production. He asserts that Tesla is uniquely positioned to address each of these challenges effectively. The prevailing uncertainty regarding market readiness for humanoid robots underscores the imperative for companies to validate demand across diverse sectors such as shopping malls and hospitals. This factor could have significant implications for future sales trajectories. Tesla's Optimus stands to benefit from its well-established manufacturing infrastructure and its integration with advanced artificial intelligence systems, providing it with a competitive advantage in the burgeoning robotics market. This strategic positioning supports the bot's long-term viability. While XPeng's Iron Robot excels in terms of aesthetic appeal and human-like movement capabilities, demonstrating remarkable technology during public showcases, the practical application of these advancements remains an essential challenge that must be addressed. The video highlights that Optimus learns from its experiences, enhancing its movements and responses through real-time data analysis.
This transformation signifies a pivotal advancement in robotics.
The robot showcases remarkable balance and reflexes, instinctively adjusting its weight to execute complex movements. This reflects significant improvements in its design and control systems. Elon Musk confirmed that the robot operates entirely on AI, a notable shift from earlier demonstrations that involved human control. This clarification bolsters the credibility of Tesla's technological advancements. Martial arts training serves as a vital testing ground for attributes like agility and balance, essential for real-world functionality. This training extends beyond basic tasks such as walking or manipulating objects. Reinforcement learning enables the robot to learn from its mistakes, enhancing its movement efficiency over time. Such advancements could shorten Tesla's training cycle from 6 months to merely 6 weeks. The neural motion network facilitates real-time movement analysis and adjustments, allowing the robot to learn from actual experiences. This capability significantly boosts its adaptability and intelligence. The training process includes uploading error data to the Dojo supercomputer for comprehensive model retraining, benefiting all robots in the network. This approach ensures a collective learning experience across thousands of units. Optimus's capacity for learning through physical experiences, such as maintaining balance during combat, signifies a shift toward embodied intelligence, an ability that simulations cannot replicate. Tesla's dual neural safety net empowers Optimus to learn safely in real-world environments, transforming physical experiments into controlled processes, which is essential for effective training in various industrial settings. Designed to supplant human labor, Optimus robots present cost-effective solutions for companies, promising a rapid return on investment. This innovation has the potential to reshape labor dynamics across multiple sectors. Elon Musk envisions a future where each robot acts as a digital worker, generating income for its owners and fostering a new rental economy. This model could fundamentally alter how businesses engage robotic labor. Despite production hurdles, Musk remains steadfast in his belief that humanoid robots could account for a significant portion of Tesla's future value. This ambition underscores a broader goal of attaining a fully automated society. China is swiftly establishing itself as a frontrunner in humanoid robotics, with companies like Unitree and Fourier Intelligence launching consumer-ready models. This competitive landscape presents challenges for Tesla. Despite facing setbacks, Musk's ambitious vision for Optimus as a platform performing human-like tasks endures. This strategic communication aims to redirect attention from current challenges to future possibilities. Mechanical failures in Optimus's design, particularly concerning its arms and hands, have stalled production. These challenges highlight the crucial importance of precision and durability in humanoid robots for optimal performance. Elon Musk advocates that fear of failure should not stifle innovation, promoting continuous improvement through a cycle of building, testing, and refining their technology. The intricacy of mimicking human-like movements in robots poses a significant challenge for Tesla, particularly regarding the tactile feedback required for delicate tasks, a capability conventional industrial robots lack. Tesla's bold aspirations for mass-producing Optimus face skepticism, largely due to the prevalent challenges in robotics, such as achieving fine motor skills and establishing cost-effective manufacturing processes. Tesla Bot Gen 3 serves as a practical tool for daily life, focusing on tasks such as cleaning and home security. This functionality starkly contrasts with flashy humanoid robots designed primarily for display. In contrast to many existing humanoid robots, Tesla Bot Gen 3 boasts advanced spatial awareness and adaptability, enabling effective navigation and cleaning across various home environments. The hands of the Tesla bot exhibit precision with 22 degrees of freedom, allowing it to execute complex tasks, such as folding cloths and handling fragile items with exceptional care. Optimus leverages AI to monitor homes, discerning behavior patterns that help differentiate between normal and abnormal activities, highlighting its advanced observational capabilities. Elon Musk envisions that Optimus's functionalities could transform crime monitoring, presenting a future where offenders are overseen without the need for imprisonment. The cooking capabilities of Optimus embody a significant challenge for humanoid robots, as successful meal preparation demands real-time adjustments and refined motor skills. Optimus can tackle intricate kitchen tasks, such as preparing breakfast, which necessitate advanced coordination and adaptability, distinguishing it from conventional industrial robots. The financial potential of Optimus is notable, with abilities to generate income by undertaking a variety of jobs, potentially leading to a novel economy powered by humanoid robots. Although the emergence of humanoid robots like Optimus may displace certain jobs, it will simultaneously create new roles in robot training and maintenance, symbolizing a shift towards human-robot collaboration. The design of the new Tesla Semi emphasizes aerodynamics and weight reduction, significantly enhancing energy efficiency and driving range, offering a competitive advantage in the freight sector. While LFP batteries were chosen for their cost-effectiveness and safety, their lower energy density posed challenges for long-haul performance. The transition to higher-density batteries effectively addresses these limitations. Transitioning to 4,680 batteries will improve energy density, reducing the number of cells required and consequently lowering the truck's weight, which is essential for maintaining performance and efficiency. Tesla's new ultra-fast charging system reduces charging time from 40 minutes to just 30 minutes, minimizing delivery downtime and maximizing operational efficiency for fleet operators. A comprehensive design overhaul focuses on optimizing aerodynamics, reducing the drag coefficient from 0.36 to 0.33, substantially improving energy efficiency and extending driving range. The use of lightweight materials in the 2026 Semi enhances payload capacity and range, ensuring that performance remains unaffected during heavy-duty operations. The introduction of advanced sensors and cameras on the Tesla Semi elevates its capability to navigate complex driving conditions, enhancing safety and overall driving efficiency. Tesla's ambitious goal of producing 50,000 semis by 2026 marks a significant shift towards sustainable freight transport, potentially transforming logistics operations substantially. The establishment of Giga Semi enables high-volume production while integrating advanced technologies, aiming to drastically decrease assembly times and production costs. The production speed of 4.5 seconds allows multiple Tesla vehicles to be built while you wait for coffee, exemplifying extraordinary efficiency and showcasing Tesla's innovative manufacturing approach. Tesla's 5 factories worldwide, including gigafactories in Berlin and Shanghai, play essential roles in producing various models efficiently, utilizing advanced robotics and automation to maximize productivity. The Gigapress revolutionizes automotive manufacturing by enabling large sections of vehicles to be cast in a single piece, significantly simplifying production complexity. The Gigapress can cast 5 chassis units in one cycle, replacing over 400 welds and streamlining the assembly line, enhancing manufacturing efficiency while reducing operational costs. Reducing weight through large aluminum castings enhances vehicle performance, driving range, and feel. This is particularly crucial for electric vehicles, where every pound has significant implications. The production process is highly automated, featuring robotic arms that execute tasks with precision, which accelerates assembly while minimizing errors. This efficiency is vital for achieving Tesla's goal of one vehicle every 33 seconds. Innovative techniques in the assembly process include bolting seats directly to the structural battery, enhancing strength and safety, and ensuring a stable vehicle structure. The upcoming Model 2 is designed as a compact urban hatchback with a streamlined feature set, targeting everyday driving needs while aiming to reduce production costs. The Tesla Bot Gen 3 is designed to undertake various household tasks, such as cooking and cleaning, positioning itself as a desirable option for consumers. Its anticipated launch is set for the upcoming year. Elon Musk's design decisions for the robot consciously eschew a human-like face, aiming to alleviate potential consumer discomfort. This approach acknowledges the influence of the uncanny valley effect, a significant consideration in the field of robotics. One of the most intricate aspects of the robot's design lies in its hands, which incorporate 26 independent motors that emulate human muscle movements. This engineering complexity distinctly differentiates Tesla's robot within the competitive market. Optimus Gen 3 employs a decentralized